Welcome back, everyone. In the previous lecture, we learned a little bit about the theory of how we're actually going to set up our time sequence data for a basic recurrent neural network. Now let's actually code it out. Let's jump to the notebook. All right, I've gone ahead and started by just having a couple of basic imports, torch and torch.nn, as well as numpy, pandas, and matplotlib. Let's go ahead and begin by creating a sine wave dataset. For this exercise, we'll look at just a simple sine wave, and then we'll move on in the next couple of exercises to actually explore kind of real time series data. But for right now, let's really just focus on how we prepare the training data and how we forecast using a recurrent neural network. Let's start by creating some data. I'm going to say x is equal to, and we'll call torch.linspace, which stands for linearly spaced. And basically what we do here is we set a start, a stop, and then how many points do I want in between that? So I'm going to ask for 800 points. So if I take a look at x, it's essentially the numbers 0, 1, and if we keep going down, all the way until 799. So it's 800 points, evenly spaced between 0 and 799. Okay, so I have x ready to go. Now let's go ahead and define a sine wave off of these points. So essentially what we're going to do here is we'll say y is equal to torch.sin for sine wave. Lucky for us, we can simply just call sine. It's a built-in function within torch. And then we'll say x. And what I'm going to do is say x times 2 times pi. So I'll go ahead and say 3.1416. And then to kind of play around with the frequency, I'll go ahead and say divided by 40. And as always, you can kind of play around with these values. But essentially what this is going to do for me is if I take a look at the values for y, this is essentially a sine wave that goes from -1 to 1. And let's go ahead and plot this out so we can see it. We'll go ahead and say plt.figure, and this all needs to go within the same cell. So we'll say then fig size. I'll make this a little larger, maybe 12 by 4. And then we'll say set some limits, just pltxlim. We'll go ahead and start from -10, just so I can see that it starts at 0. And then we'll go up to 801, so I can see a little bit of the end there. And then we'll go ahead and say plt.plot, and I'm going to plot y, but remember y is a PyTorch torch object, so what I need to do is convert this into a numpy array. And let's go ahead and in between these, let's add a grid to this so I can read it. We'll say plt.grid is true. So if you run that, that should visualize the plot for you. The reason I'm starting from x -10 is just so I can see right here this little point in 0. If you want, you can set the limits to 0 and kind of set it up here, but I like being able to see that little starting point for the visualization. And here we see the sine wave going from -1 to 1, and we can check out kind of our frequency of points here, and we're going all the way up to the very end around 799. Okay, so we have our sine wave. Now the part we really want to focus on here is creating a training set and a test set. So let's go ahead and take the first 760 samples in our series as a training sequence and then save the last 40 for testing. So since we're actually going to try to forecast into the future, we don't actually do a random train test split. Instead, we decide that we're going to take some portion off the very end of this data and never let our network see it. And then we'll train on the rest of this sine wave. And then at the end, we'll try to forecast onto this test set or this test range, and we'll see how well we perform. And then if we want, we can continue forecasting into the unknown future, which is essentially the exact same process as forecasting onto the same range as the test set. So what I'm going to do here is, again, we're doing a sequence train test split, which is different than a random train test split. So I will say my test size is 40. And that basically says I'm going to save the last 40 points in my sequence to use them for a comparison using my recurrent neural network, which then means that my training set is going to be equal to my y points, and we'll start from the beginning all the way up to minus the test size. And then I will have my test set be equal to my y points, and that's going to start essentially 40 points back and go all the way to the end. So now that I have that, I can go ahead and let me copy and paste this right here, and I'm going to grab the training set and plot that out just so I can visualize what I just did here. So notice right now I have this training set portion, and it only goes up to maybe a little past 750. essentially just 40 points back from 799. So here we can see our full test set actually goes all the way to 799. So essentially, we've chopped off that very end, and we're going to train on this data that I see here in my train set, and then we'll try to forecast into the future into the same range of the test set that I already know, and then we'll be able to compare results and see how good our prediction is. And then if we want, we can then extend that forecast further into the unknown future. The problem with that, though, is we won't be able to actually understand how well we're performing since we technically don't know that data. The next thing we need to do is take that subset of the training data that we now have available to us and prepare it into those training sequences. Those are essentially those little windows we were talking about in the previous lecture where we have maybe 5 data points in order to predict the next point. So keep in mind, it's almost like we have kind of 2 train test splits happening. We have our initial one where we chop off that very end of the data in order to do some sort of final test comparison. And then within this training data, we're going to separate this out into little batches that have their own little training set of a couple of data points along with a corresponding label, essentially the next point in the sequence. Let's create a function that does this for us. We're going to say, have a function called input data. It takes in the training sequence and then WS, which is going to stand for window size. And essentially what this function does is it takes in all this data that's available for training and then chops it up into batches, the size of the window with then one prediction point into the future. So I'm going to have an output be an empty list, and at the end of all my operations, I'll return that output. So what I want to do is this output is going to be a list of tuples, where the tuples are essentially points maybe like 1, 2, or 0, 1, 2, 3, comma, and then the corresponding label for the next item, which is 4. So that would be 1, and then the next one's going to be something that looks like this. It would be 1 shifted over, 1, 2, 3, 4, and then the corresponding label for that one would be 5, and then so on and so on. Essentially, we're just creating the batches that we just discussed in the previous lecture. So how do we do this? One thing we need to be careful of is we have to make sure that we don't actually extend past the available training data. So what we're going to do is we'll define capital L as the total length of our sequence. And in this case, our sequence will be all the data available for training. Then we'll say for I in range, and here's where sometimes beginners get confused. They expect us to go all the way up to the end. But remember, we're grabbing these sequence points and then the predicted next value. So we can't go all the way to the end because we'll eventually run out of points. We'll be trying to grab points that we don't have available for us in the training data. So we can go only up to L minus the window size. And then what we're going to do as we kind of chug along here, we'll grab that window of information, which is essentially the sequence, starting at I, go all the way up to I plus the window size, and then grab the actual label, which is essentially this second item. So 4 or 5, etc., whatever happens to be. That's going to be starting at the very end of that. So at I plus the window size, go all the way to I plus the window size plus 1. So in this particular case, we are deciding that the label will just be 1 point into the future. I would say for most sequence tasks, that makes a lot of sense to, based off a prior sequence of data, go ahead and just predict 1 point into the future. Because for the purpose of forecasting, we can then just repeat that process regardless of how many points we actually want to predict into the future. Recurrent neural networks tend to work best when you're just predicting 1 point into the future. And that way, when you're actually forecasting many points into the future, you just repeat the network's process of predicting that 1 point into the future. So here we're going to have our window. And again, for the window size, that's kind of up to you. And again, it's always going to be dependent on your data. If it's seasonal data, you want to capture at least 1 season worth of information. So for example, you could decide that WS should be 12 if you're dealing with monthly data that shows kind of a yearly seasonality to it. At the end of this, we're going to append a tuple. So I'm going to set parentheses inside of this, where I have my window and my label. And then at the end of this, I return that out. So here's my input data. And recall from above here, we have our test size, the training set, and the test set. So let's go ahead and set a window size. So one entire cycle for this is going to be 40 points. So I will say that my window size is equal to 40 points. Again, this is what you're going to have to play around with, use domain knowledge, experiment with in order to figure out what window size works best for your problems. Next, we want to create the training data set of sequence and label tuples. So we'll simply say my training data is now going to be the result of input data, then pass in my training set along with the window size I just defined. So when I run this, if I were to check the length of my training data, it's 720. Well, does that make sense? Recall that our original number of points goes from 0 to 799. So that gives us a total of 800 points. So that means after subtracting that final test set, 800 minus 40, that results in 760. And recall that our window size is 40, so 760 minus the window size of 40 ends up resulting in 720, which is exactly what we have here for our training data. So it looks like all of that worked out. Let me go ahead and comment that out, and we'll continue now. So let's go ahead and just explore this training data a little bit. If I take a look at my training data, it's essentially this list of tensor values. So here's the tensor values of 40 points along with the very next label. So let's just grab one of these, the very first item, and we can see here what it looks like. Here's the 40 points, and then the very next point in the sequence. Let's go ahead and look at this one step further into the future. And you'll notice that now we're no longer looking at the initial at time step 0, but now we're starting at time step 1, and then the previous prediction label is now the very last one here, and then we have the next one going from 0.15. And then if we were to repeat this over and over, you would keep seeing us shift further one to the right. Okay. So this concludes part 1 of just setting up the training batches. Up next, in the next lecture, what we're going to do is we'll define the LSTM model, instantiate the model, and define loss and optimization functions. I'll see you there.